So let's just talk about linked list. So the linked list is a linear data structure that consists of nodes connected by pointers. So the nodes are the building blocks of the linked list. So to create the linked list, we need to have multiple nodes and the nodes should be connected by pointers. So in contrast, the array requires contiguous memory location. So in an array, we have memory location which is contiguous, means they are in sequence one after another, and here we have the fixed size, where in case of the linked list we have complete flexibility. So here we can dynamically allocate the memory, and because of this we can grow and also we can shrink the size of the linked list as needed. So that is the main flexibility of linked list. So the node in the linked list has the data part and the address part. So here we store the data and here we store the address which is pointing to the next node. So this is the node which is the building block of the linked list. So the data is the actual value like a number or name or anything that can store, and the address part is the address of the next node in the list. So suppose we wanted to store the numbers like 4102 using linked list. So for that we have to create node for each of these numbers. So let's just create them. So here we have the 4 nodes. Now the 4 is the data, so the number will go in the data part. So 1 will go here, 0 will go here, and 2 will go here. So all of the numbers will be stored in the data part of the node, and all the nodes will have its own address. So the first node can have the address like 1000, second node can have the address like 2000, and so on. Now to create the link between them, the address part of the first node will contain the address of the second node. So here it will contain the address 2000. This way the first node is pointing to the second node. Similarly, the second node will hold address of the third node, so it will have the address 3000. Similarly, this will hold the address of 4000 last node, because after that we do not have any node, so it will contain null. This signifies that this is the end of the linked list. So this way we can create the link between multiple nodes. So this is how we can create the linked list. So this is one example of the singly linked list, because here each node contains a pointer to the next node in the list. So here the navigation is only in the forward direction. So that means we can traverse the list from the first node till the last node, and we can do it in the backward direction. So this goes in the forward direction only. So here in the list there is a pointer called head pointer. So this contains the address of the first node. So now we can start from the head node and we can follow the link to access all the nodes until we reach null. Null means this is the end of the list. So let's just talk about the type of linked list. So there are 3 primary types of linked list. So first of all, we have the singly linked list, doubly linked list, we have the circular linked list. So in a singly linked list, all the nodes contains the address of the next node. So each node pointing to the next node in the list. So here the navigation is possible in the forward direction only. So here we cannot go backward in the list. That is why it is the singly linked list. And secondly, we have the doubly linked list. So in a doubly linked list, each node contains pointer to the next node, to the previous node also. So here this node contains to the next node, and also it has a pointer to the previous node. So the last node will have a pointer to the previous node, and the next will contain the null, signifying that this is the end of the list. So here each node has pointer to both the previous and the next node. Because of this, here the bidirectional traversal is possible. And thirdly, we have the circular linked list. So the circular linked list is similar to the singly linked list. Here also we have links to the next node, but the only difference is that the last node points back to the first node. This way it creates one loop or circle That's why this is called the circular linked list. Now in a linked list, to traverse or access all the values of the linked list, we have to start from the head node because this contains the address of the first node. So we start from the head node and follow the link of all the subsequent nodes until the null. The null signifies that this is the end of the list. So this way we can traverse all the nodes of the linked list. So in a linked list we can perform multiple operations. We can perform the insertion of one node in the linked list. We can perform the deletion of one node. We can perform traversal of the entire linked list. And fourthly, we can search for one node in the linked list. Now let's just talk about the advantages of using the linked list. So first of all, here we can perform dynamic memory allocation. So here we do not have any fixed memory size. We can allocate the memory whenever it's needed. So this is the flexibility in case of linked list. And secondly, here we have the efficient insertion and deletion, which was not possible in case of array. So here we can easily add or remove nodes. And thirdly, here we have the efficient memory utilization. So because the nodes can be stored anywhere in the memory, they don't need contiguous memory locations like in case of arrays. So arrays need contiguous memory locations, but the linked list can be anywhere in the memory. So all the need is to point to each other using the link. So we have to just link between them. So these are the advantages of linked list. So let's now talk about the disadvantages of using the linked list. So first of all, here we have some overhead because here we have to maintain multiple nodes to set the link between them. So here each node requires this extra address field, which is a memory overhead. And secondly, we have some problems in case of the sequential access of all the data. So if we wanted to access a specific element in the node, then we have to traverse all the way from the head node. So we have to start from the head and we have to traverse all the way to access one specific element. But in case of array, we can directly access any specific element using the index of that element. And thirdly, here things are little complex. To implement and manage a linked list requires some effort because here we have all this headache of we have the head node, we have the link between node and all this stuff. So all of these makes the whole scene little complex, but it has a lot of advantages also. So hope you understand about the types of linked list, the way linked list works. So hope you understand the concept. See you in the next one. Take care.